to be your friends. But the first thing you have to do is pretend you've never even seen them before. Because the minute I say tape diagrams, some of you groan. And it's understandable. But this way of using them will actually help you. It actually will make sense. And it will be a wonderful jumping off point for our unit on algebra. So we're going to start out with a pretty simple number, and we'll start out with 10. You need to think of the addition problems that could get you to 10. The most simple is 5 plus 5. You can also do 6 plus 4. You can do 7 plus 3. You can do 8 plus 2. You can do 9 plus 1. You can also flip all of these so that you could do 5 plus 5, 4 plus 6, 3 plus 7, 2 plus 8, 1 plus 9. Now let's see, how in the world does this connect to a tape diagram? So I'm going to draw my skinny rectangle. And in order to show 5 plus 5, it's the same number, so I'm going to make two boxes that are the same size. This would be 5, this would be 5. So this diagram represents 5 plus 5. To do 6 plus 4, another skinny rectangle. I'm not going to divide it in half because 6 and 4 are not the same. 6 is a little more than 5, 1 more than 5. It's 1 less, 4 is less, 1 less than 5. So I'm going to put it over about that far. So then this would be 6, and that would be 4. 7 plus 3. We're going to be a little further over because 7 is bigger than 6. And this is going to be a little smaller because 3 is 1 less than 4. But when you look at the tape diagram, you can tell now that 5 plus 5 is 10, 6 plus 4 is 10, 7 plus 3 is 10. We can do our 8 plus 2. Again, this is a little smaller than the 3. This is a little bigger than the 7. Back to our skinny rectangle. And now the final problem, here would be our 1, and there would be our 9. So when you're using a tape diagram to do addition, it's really clear and makes a whole lot of sense. Next, we're going to take a look at a tape diagram for multiplication. We're going to switch from 10 to 24. And then we're going to think about the factors of 24. We can do, I'm not going to do 1 times 24 because I don't feel like making that many boxes. But we could do 2 times 12. Four times 6. And obviously, because they're fact families, we could do 12 times 2, 8 times 3, 6 times 4. To do this as a tape diagram, we want two boxes that each have 12. So it's 2 times 12 equals 24. Or if you turn it back into an addition problem, 12 plus 12 is 24. 3 times 8, we need 3 boxes. So we have our 3 boxes. Each one of them is worth 8. 3 times 8 is 24, or 8 plus 8 is 16, plus 8 is 24. To represent 4 times 6, we make 4 boxes. Each box is worth 6. So then we either have 4 times 6 is 24, or 6 plus 6 is 12, plus 6 is 18, plus 6 is 24. So now the tape diagram is our friend and makes it much clearer and easier to see what we've represented.